Okay, I thought I'd start with the Dominos because it's a good random review. It's not all in one category. It's kind of all over the place, which is more authentic to your midterm. So, starting with number 1, if k is a constant, what is the value of k such that the polynomial k squared x cubed minus 6kx plus 9 is divisible by x minus 1? Okay, if you're divisible by x minus 1, then when you divide by x minus 1, there should be no remainder at all. So we should get a remainder of 0. If you get a remainder of 0, though, because this would be pretty hard to figure out, if you get a remainder of 0, then x minus 1 is a factor, and therefore the root would have to be 1. If something's a root, that means when you plug it in, it gives you 0. So when I plug in an x equals 1, k squared times 1 cubed minus 6k times 1 plus 9, I need this to equal 0 if 1 is going to be a root. And now I can find k. That's an easier way of doing it. So now it's just k squared minus 6k plus 9 equals 0. And so if I solve this as a quadratic by factoring, is it factorable? Yes. K minus 3 times k minus 3 equals 0. So teeing it up, k equals 3. Now you could confirm, you could plug 3 in and you'd do 9x cubed minus 18x plus 9 and divide by x minus 1, and you could confirm that it works. But at the end of the day, we want it to be divisible by x minus 1, which means we want x minus 1 to be a factor, which means we want the number 1 to be a root, which means when you plug it in, you'll have a remainder of 0 or a y value of 0. Number 2 wants us to solve a rational equation. So we would first factor out if we can. So on the numerator, we'll see if that's factorable. 2m and m is the only option. 5 and 1 is the only option, but the question is it 5 and 1 or 1 and 5? Just by the look of it, you can try and check both. I like 5 and 1 because this will give us 2 on the outer and 5 on the inner. 2 and 5 has a difference of 3, which is a difference because of that minus sign. So we want it to be a positive 3. So we want it to be a positive 5m on the inside, minus 2m, 5m minus 2m will make 3m. So there's your numerator. Your denominator also factors into m and m, 5 and 1, which makes no difference here because the m's both are 1m. And then we need a plus and a minus to make negative 5, but we want it to be a positive 4. So I'm going to make it a positive 5m on the outer and the negative 1m on the inner. Equals 4. So we could cross multiply, but before we do, the factoring helps with any rationals because that cancels. Now, we do have to know that m equaling 1 is an excluded value. So m definitely cannot equal 1 and also cannot equal negative 5 because those would both make the denominator 0. Anything else we get when we solve this will be the solution. So if you cross those out and simplify before you start solving, now when we cross multiply, you're just going to have 2m plus 5 equaling 4 needs to be distributed to that, so 4m plus 20. And then we'll get all of our m's together, subtract your 2m over, subtract your 20 over to the left. So you've got negative 15 on the left and just 2m on the right, divide by 2, and m equals negative 7.5. That's a solving of a rational. Number 3 brings us to what extraneous solution arises when you solve this. So we need to solve it first. So to solve a radical, you get the radical all by itself, which luckily here is already done. Square both sides. We get x plus 3 equals 4x squared. It's a quadratic, so we want to solve it and get it equal to 0. See if we can factor it, which, well, there's a couple options for 4x squared. We'll try with 2x and 2x first. That would require 3 and 1, or 1 and 3, but it doesn't matter because they're both with 2x. Our outer would be 2x. Our inner would be 6x. Unfortunately, 6x and 2x won't ever make a 1 or a negative 1, regardless. So I'm going to guess the 2x and 2x is wrong. I'm going to try 4x and x. Now 3 and 1 or 1 and 3 matters because 1's going to get paired with a 4. So I'll try this way first. That'll give me 12x and 1x. 12 and 1 is never going to give me 1 either. So if I reverse that and do 3 and 1, I get 4x and 3x. That's great. 4x and 3x has a difference of 1. So I want it to be overall a negative 1, so I'm going to put the negative sign here so that it's negative 4x plus 3x is negative x. So there's my proper guessing and checking with factoring, and then teeing it up. And then when I add 1 to both sides, this will give me a solution of x equals 1, and this one will give me a solution when I subtract 3 over and divide by 4, I'll get x equals negative 3/4. So which one is extraneous? So we got to go back to our original problem before we squared both sides and check. And I'm going to check the 1 first just because it's easier. If I plug in 1, 1 plus 3 is 4. Square root of 4 is 2 equals, and then I plug in 1 on the right-hand side, 2 times 1 is 2. 2 equals 2. That checks. If I check the negative 3/4, I might want to use my calculator for this. On the left-hand side, the square root of negative 3/4 plus 3 on the left gives me 1.5. On the right, 2 times negative 3/4 gives me negative 1.5. Does 1.5 equal negative 1.5? No. So this is the extraneous. So to answer their question, what is the extraneous solution? It actually is negative 3/4 would be your final answer because that's they're asking for the extraneous. On number 4, we're solving an exponential equation, the variables in the exponent. So 4 to the x squared over 2 to the x equals 2. Now, we can use logs, although that's a little tricky here because we have variables in exponents in 2 different places. We want to capitalize on the common bases here. So the fact that 4 is 2 squared allows us now to use our common base division rule. So, well, actually first our power to power. So this power to power means multiply, so that'll just be 2 to the 2x squared. And then we can capitalize on our, when you're dividing common bases, subtract the exponent. So this will be 2x squared minus x. And now we have common base on both sides. This side's technically to 1. So if you have common base on both sides, you drop the base, and we get 2x squared minus x equals 1. It's a quadratic. Subtract that 1 over and solve the quadratic. And let's just pretend we're sick of factoring for now, so we'll just do the quadratic formula. The opposite of b plus or minus the square root of b squared is just 1 minus 4 times a times c all over double a. 2a is 4. So that'll be 1 plus or minus the square root of, this is going to be, if I type that discriminant, 4 times negative 4 times 2 is negative 8, times negative 1 is positive 8. So it'll be 1 plus 8, which is 9, which is 1 plus or minus 3 over 4, because the square root of 9 is 3. So 1 plus 3 is 4 over 4, which is 1, and 1 minus 3 will give us negative 2 over the 4, is negative 1/2. So we have 2 solutions there. On number, let's see here, number 5, we have a system of 3 equations. So elimination 3 times. So you want to first look at your variables and see which one's the easiest to get all the coefficients the same. And guess what? These already are the same. So let's just start with our first, so we don't need any multipliers, that tells us. And if we try to eliminate our z's, there's 3 rounds of elimination, eliminate the same variable the first 2 times. So that would be the z's we're going after. So opposite signs means add. So x plus negative 2x will be negative x. Negative 9y plus 9y is 0, so your y's are gone. Your z's are gone. 4 plus negative 4 is gone. 1 plus negative 3 equals, because there's your equal sign, negative 2. So that's nice, because now we just know x is 2. On your second round of elimination here, same sign subtract is the motto, so we're going to subtract. Negative 2x minus 2x is negative 4x. 9y minus y is 8y. And then negative 3 minus negative 3 is 0. So this is nice because we already know x. You know x is 2, so negative 4 times 2 is negative 8. Plus 8y equals 0. Add this 8 over, solving for y. So y equals 1. And if you know x and y, you can go back to any one of the originals and find z. I'll go to the first one. So x is 2 minus 9 times your y of 1 plus your 4z equals 1. I'm just copying that down, and I'm about to solve for z. I'll subtract this 2 over. This is just minus 9, so I'll add 9 over. So I get 4z equals 1 minus 2 is negative 1. Negative 1 plus 9 is 8. Z equals 2. And there's your answer. X is 2, y is 1, z is 2. They asked for the value of z, so that's why the answer here is just 2. Z is 2. Number 6 is going to look at radical rules and try to figure out, and let me rewrite this so it's like side by side. So they're looking for the square root of the cubed root of x plus 1 to the 5th, and they want to know that it equals x plus 1 to some a power, and what is a? So we have to use the fact that radicals are exponents in a lot of ways. So working from the inside out, if we're taking the cubed root of x plus 1 to the 5th power, taking the cubed root is the same thing as raising something to the 1/3 power. And then there's a big square root over all of that. Well, taking the square root of something is the same as raising it to the 1/2 power. So it builds up this power to power to power thing, which we know we then have to multiply. So to multiply fractions, to get that 5 over 1, you just multiply the numerators. 5 times 1 times 1. Oops. X plus 1 is our base. 5 times 1 times 1 is 5. Over 1 times 3 times 2 is 6. So that answer is what A is. A is, well, technically there. Cross out your bases, because now they're the same, and 5, 6 equals A. If we move to 7, find the A value of the parabola that has a focus and a directrix. So always a sketch with focus directrix problems. So your focus, -2, 1, 2, 3, 4, 5. Your directrix is at y equals 1. Directrixes are lines. So we have to place our vertex, which is always halfway between the focus and the directrix. So if you count, there are 1, 2, 3, 4 units between these two. So the vertex is going to be kind of halfway in between, right there, which has an x-coordinate of -2 and a y-coordinate of 1, 2, 3. And then your parabola always bends away from your directrix. It can never cross it. So there we are. So for this equation, you have to remember your flashcard info, plus or minus 1 over FD, 2 times the distance between the focus and directrix, x minus h squared plus k. So you pick your plus or minus because this opens up. It's a plus. 1 over, and it's the A value, which is here, always comes from double the distance between the focus and the directrix. So you just count that. 1, 2, 3, 4. So the distance between them is 4. We need twice that distance. 2 times 4 is 8. And then HK is your vertex. So x minus -2 will turn to x plus 2. and then plus your k value of 3. So the A answer is 1/8. For number 8, we're essentially determining the smallest x value for which this function will equal this function. We're essentially trying to solve this. This is a mixture of like an absolute value equation solving with a quadratic. We don't know how to do this by hand. This is too complicated. So we will treat this like a system of equations where this is one function, this is another function, where do they cross? So if you go to your y equals menu so you can type these things in, we have to get our absolute value. So there's x minus 4 plus 1, which is just an absolute value parent graph shifted right 4 and up 1. So a negative 10 to 10 window would work fine for that. And then this is a parabola parent graph just shifted up 3. So again, the window from negative 10 to 10 will work for that as well. Now, it may not show the intersections, but actually it does. We do get both intersections, so we don't need to change our window. They want the smallest x value for when this happens. So that's a positive x value solution. Positive 1 it looks like. We want the negative x value. It looks like it's about negative 2, but I'm going to let my calculator do the work. Second trace and option 5 intersect. Bring your cursor to the left. It's on your first curve, which was the first absolute value equation you plugged in. Enter. Then your cursor jumps to the quadratic, which was the second one you plugged in. Enter. Guessing, we just hit enter through that, and the x-coordinate is negative 2. So that's the smallest. X equals negative 2. And you could honestly check it if you wanted extra confirmation. If you plug in negative 2 to the left, you're going to get 7. Plug in negative 2 to the right, you're going to get 7. 7 equals 7. Number 9, exponential application. After d days, there's d in the formula, the number of grams of an element remaining in a dish is given by this function. R of d equals 7.35 times 0.5 to the d over 2. So we're losing 50% every 2 days. So this is like our 1 minus our rate would have to have been a 0.5. So this tells us we're losing 50% every 2 days. How many days until only 1 gram is remaining? So our final amount is 1. Now, honestly, I didn't really need to process all that I just explained there. I just need my final amount to be 1, and I'm just solving for d. So divide over the 7.35. I'm afraid of the decimal that's going to be, so I'm just going to leave it. Log both sides, natural log both sides, or log base. The base of the exponent is 0.5, so log base 0.5 on both sides. That'll cancel that. And then you'll have d over 2 equals log base 0.5 of 1 over 7.35. And then to solve for d, times 2 times 2. So d equals 2 times, then we have to go to our math, scroll all the way down to find our log base 0.5, 1 over 7.35, and d equals 5.755, and I see that as my final answer, and I immediately go back and say, what did they want me to round to again? Nearest day, so 6 days. There it is, 6. Okay, find the radius of the circle. So this is like completing the square. This one's actually pretty nice for you because the x's are already grouped together, plus the y's are already grouped together, and the constant's already on the other side. So sometimes you have to rearrange yourself. But to complete the square, we take on the x's half of the b term, so half of 4 is 2, and square that, that's 4. So we have to add 4 in there, and add 4 on the right side to counter that, so to keep everything all equal. On your y's, half of negative 6 is negative 3. Negative 3 squared is 9, so we have to add 9, add 9. Now you're factoring this, which will factor into x plus 2 times x plus 2, which is x plus 2 squared. factoring this, which will be y minus 3 times y minus 3, which is y minus 3 squared, which is no coincidence. We chose this number so that that beautiful thing would happen. And then equals 16 plus 9 is 25. So your circle has a center at negative 2, 3, and a radius of the square root of 25 is 5. So radius answer there is 5. And one more, number 11. A radioactive substance has a half-life. Half-life is the amount of time it takes to lose half of its material. So of 10 years. So we're using our basic exponential growth decay. We are losing half of our amount, so losing 50% every 10 years. They want the yearly rate of decay. So they're just asking us to change the rate to a 1-year rate. So all we have to focus on then here is here and plugging in a 1. When I do that, 1 minus 0.50 to the 1/10th power, I get a new base of 0.933 to the t over, and I just change it to a 1-year rate. Now the question is, what is the actual rate that we lost? So this is the same as 1 minus something, and it wants it to the nearest percentage, so I could kind of just have treated that as 0.93. We lost 0.07 to make that happen, so it's a loss of 7% and on a yearly basis. And that is the end of the domino.